All right, so today we're going to continue our discussion on solving equations. Yesterday we focused on equations that were exponentials that we had to use logs to solve. Today we're going to focus on solving equations that only have logs in them. So it's just going to continue learning techniques of solving equations that either need logs to solve them or already have logs in them. So the technique I wanted to put on display right here is we have this log equation, and what we're going to do is take that log equation and put it into exponential form in order to solve it. And the reason I have to do that is the x is trapped inside of the log. We need to free it. So the base of this log, since we don't see one there, is base 10. So recall, if you don't have a base listed, it's going to be base 10. So we can go to exponential form by writing the base, which is 10, to the power 4, and then it equals x minus 2. So one thing we really need to solidify is the fact that this log equation is the same as this exponential equation. It's just log form versus exponential form. Then I can solve this by finding 10 to the 4th power. That's a 1 with 4 zeros. Or 10,000 equals x minus 2. And then I'm going to add 2 on both sides to solve. So 10,002 is going to be your x value. So that is kind of displaying, putting the equation into exponential form. And we would do that if we have an x trapped inside of a log. Notice here we have our x trapped inside of our log, but I have a whole bunch of stuff around my log. So first, I really want to isolate the log. So I'm going to add that 5 to both sides. And then I can divide by 6 to isolate the log. So I get the log base 3 of 4x equals 2. So I have done what I set out to do, which is isolate the log first. Now I can go to exponential form. And going to exponential form frees the x from the log. So it is the base is 3, so it's 3 squared equals 4x. So I've now freed the x from the log, and then I just have to divide both sides by 4. So this is 9/4, just calculating what 3 squared is. So, same technique as we went over last example, which was going over exponential form, going through exponential form to get to our answer. But in this one, we had to isolate the log first, so get the log by itself. So this one, we have 1, 2, 3 logs. But you will notice on the left side that these logs are being subtracted. So we learned log properties that highlighted how to go from multiple logs to 1 log. So the technique this problem highlights is writing as a single log on each side. So recall, when you are subtracting 2 logs, we can write those as a single log with the insides being divided, because the conversion goes between subtracting on the outside of logs to dividing on the inside of the logs, and that equals log of 3. So notice now we have log, 1 log on one side, 1 log on the other side, and those logs are the same. They're both base 10 logs. So if you have the same logarithm on both sides and just 1 on each side, then the inputs into the logs must be equal. So in other words, x squared minus 1 over x minus 1 has to equal 3. So what we can now do is cross multiply, since we have kind of fraction on one side, fraction on the other side. So multiplying along one diagonal, I get 3x minus 1. Multiplying along the other diagonal, I get x squared minus 1. And then what I could do is bring the 3x over to the other side, because since this is a quadratic, it would be good to just get a 0 on one of the sides, and then I can also add 1 to both sides. So that'll cancel out those two, and then I'd get 0 equals x squared minus 3x. And to solve, we can factor out the greatest common factor. So the greatest common factor is 0. Is x. And then if we set each factor to 0, I get x equals 0 and 3. Now if I look at my original function, let's see if I can fit it on the screen. There we go. If I look at my original function, notice it's log of x squared minus 1, log of x minus 1, and log of 3. I want you to take note that the inside of logs must be positive. So that's one of those little facts that you just have to file away and hope that you'll remember come test time. The inside of logs must be positive. And so one of these values makes the inside of the logs negative. So if I plug in x is 0, notice I'll have a negative inside that log. I'll have -1. Here, if I plug x is 0, again, I'll have negative inside the log. So 0 we have to eliminate as a solution. So really our only solution is going to be x equals 3. Due to the fact that the input into logs must be positive. So that's one of those tricky things that, yeah, you just have to keep in the brain. So this one's a little different. I don't have logs on both sides, but I do have multiple logs on the left. So the technique I'm going to use is I'm going to do as I did last time. I'm going to write multiple logs as a single log. So that's kind of a trend here with our techniques. Write as a single log on the one side. So these are being added. So 2 logs being added, we can combine those into the log of a product. In other words, they're being multiplied on the inside of the logs. So it's a log of x minus 5 times x plus 5, log base 12, and that equals 2. I might as well go ahead and multiply those together. I don't really see why not. So if I multiply those together, I get x squared. The inner and the outer term cancel because negative 5x is the inner term and positive 5x is the outer term. So those cancel out. So the inside of this log is just going to be x squared minus 25, and that equals 2. Now you'll notice now that we've simplified the left side, this is just a single log. So if you have a single log, you have to use exponential form. If you have logs on both sides, then you're going to probably just be able to look at if the logs are equal, then the insides are equal. Here we don't have log on both sides, so we have to go to exponential form. So we say the base, which is 12, to the second equals the input of that log, x squared minus 25. And then I can calculate the 144 for 12 squared. Add 25 to both sides. And typically when we would solve, we would do the positive or negative square root to solve for x. So it's plus or minus the square root of 69. In other words, plus or minus 13 equals x. Well, thinking about what we had to consider, the fact that the input into the logs must be positive. Well, if I plug negative 13 into my log, I'm going to have negative 18. I'm going to have negative 8 there. So that's not going to work. So the only one that actually works is 13. So I have to check to make sure what I plug in actually doesn't provide a negative inside a log. And then, yeah, that should be it. All right, so today there's a worksheet to do, and it doesn't have a title. It's just problems 13 through 26 on the worksheet. All right, have a good day.